Here. Today we are graphing and writing piecewise functions. A piecewise function is a function built by two or more equations. So do you see how this graph has two or more equations? Each equation has a specific domain. Remember, domain is x values that is assigned to that piece called a constraint. So we're going to be graphing the line y equals, remember f of x means y equals 2x plus 1, but only when x is less than 1. And we're going to graph the line y equals negative x plus 4, but only when x is greater than or equal to 1. So what we want to do is we want to split our graph into two pieces. One piece where x is less than 1 and one where x is greater than 1. So looking at your graph, we're going to find where x is 1, which is right here. And I'm going to shade the graph. Now, it is very possible to graph these without doing the shading, but doing the shading can help you figure out what you're supposed to be doing. All right, so we said x is 1 right here, and so this is where I'm going to start my shading. And I'm going to choose to shade this side where x is less than 1. So I'm going to shade all of this. Should I have a better one for myself? This one. All right. I need to graph this line, y equals 2x plus 1. The equation of a line, remember, follows mx plus b, where b is your y-intercept. And m is your slope. Your slope, of course, is rise over run. Now this should be review, but maybe it's been a while since you've graphed a line. So we're going slowly through that. Yeah. Better? Okay, so I like to start at my y-intercept of 1. I'm going to make a point. I'm not making it super dark because I'm going to have to erase some of these things. My slope is 2, but I need it to be a fraction, so it's rise over run. So 2 is equal to 2 over what? It's over 1. Good. So anytime you have an integer, just put it over 1. 2 over 1 is the same as 2. And now I know I can go up 2 and write 1. Up 2 and write 1. Up 2 and write 1. I do it several times to make sure that when I draw my line, it's very accurate. Oh, see, I still got off. I'm going to fix it. It wasn't that good. Okay, so that one's a little bit better. Notice I made my line go all the way across the page. Just to back up for a moment, the first thing I did was I graphed 1 on the y-axis. I made that point. And then I did a slope of 2 over 1, so I went up 2 and right 1, up 2 and right 1 several times. And then I drew my line all the way across the page. Now I only want that line when x is less than 1, so only in this shaded area. So I'm going to erase all of this. And my line starts right there, and it goes this way. And then the last thing I have to figure out is whether the endpoint there is solid or empty. So this is my y-intercept. That's not the endpoint. The endpoint is up here. If it says y is less than 1, does that include 1? If y is less than 1, does that include 1? No, right? It has to be less than 1. So to show that we're not including 1, you make an open dot at that point 1, 3. So anytime you have a less than or a greater than, you will use an open dot. And when it says less than or equal to or greater than or equal to, you'll use a solid dot to indicate we're including that point.
That's the high point.
It's kind of the end point, but it's open, so it doesn't include that point. But yeah, you could think of it that way.
So I should erase the stuff after.
Yes. So did you guys see that? You're erasing this part, you're graphing this part. You should be graphing along with me. Okay, the next one, your y-intercept is 4. So I'm going to graph the 4. And my slope, I don't see a number in front of the x. It just says negative x. What number is in front of x? Negative 1's right. So this is a negative 1x, and I can put it over positive 1, just like I put the 2 over positive 1. So my slope is negative 1 over positive 1. You can't make it negative 1 over negative 1 because then the negatives would cancel. So negative 1 over 1. So starting from 4, go down 1 and over 1. Did I go to 4? 1, 2, 3, 4. Oh, thank you. I was like, I'm off for sure. 1, 2, 3, 4. So starting at 4, I'm going down 1 and right 1. And I'm going to do several points to make sure I don't get off track. And then like that. Okay, so notice for the first line, I erase the part on the right. For the second line, I only want x's greater than or equal to 1. So greater than or equal to 1 would be this part. I want that part, and I get rid of this part. Okay, so the first line is for the left side, and the second line is for the right side. This point right here is tricky. It was an open dot for the first one, and then it was a closed dot for the second equation. If it's open for one and closed for the other, it's just closed. We're including that point because we're including it for the second function, so don't try to make it look like both open and closed. It's just closed. All right, for this one we have 3 sections. So your graph is going to be in 3 different sections. Just to minimize the amount of coloring I have to do, I'm just going to color the middle section and then I'll be able to see all 3 parts. If you had 3 colors, you could color all 3 sections. But I'm just going to color this middle section. All right, so I need the x's from negative 4 to 2 for the middle section. So I'm going to go back to where x is negative 4. 1, 2, 3, 4. And then I'm going to go up to where x is 2. And then I'm going to color in that middle section to help me focus on that one. And the reason I chose to color the middle section is because now I can see all 3 parts. It just minimized the amount of coloring I had to do. But like I said, if you want to, you can color all 3 sections different colors. All right. The first one is in y equals mx plus b form, so we can graph it with the same way we did here. Start with your y-intercept at 8. And be careful, because I think this graph only goes up to 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8's right here. And I have to do a slope of 3 over what number? What do we put 3 over? 1, yeah. All right, so you'll notice we get off the graph. You can estimate 1, 2, 3, 1 like that. But estimating's not really the best way to go. So what we're gonna do now is we're gonna work backwards. So instead of up 3 and right 1, we're gonna go down 3 and left 1, just to continue that line. 1, 2, 3, 1. You see what I'm doing? I'm just going backwards so that I can get more points on this line. Because I'm not even in the section I want to be in yet. I want to be x is less than or equal to -4, which is all the way over here. So I have to keep backing up. 1, 2, 3, 1. 1, 2, 3, 1. That should be enough. So I started at 8 on the y-axis. I went up 3 and over 1, but I was like way off the graph. And so then I went backwards, down 3 and back 1. Now I only want this when x is less than or equal to -4, which is over here. So I only want this part. And it says or equal to, so I can keep a solid dot here. And then I'm going to go down with an arrow. And then these dots I erase. Because that center part, that's for the second function. So I made the dots all the way across, but then I only kept this part because this is where x is less than or equal to -4, this section here. The second part of the function is called a constant function. A constant function is where the y is always going to have the same value. So the y is always -1, which makes a horizontal line. So we have a horizontal line at y equals -1. I'm going to draw it in very lightly because I know I'm going to erase part of it. Okay, you can almost not even see I drew something there. It's right here at y equals -1. We want that one between -4 and 2, which is my shaded section, so I only want it in here. Look at the -4 and the 2. Which one is going to get an empty dot? Is the empty dot at the -4 or at the 2? -4, yeah, because there's no equal sign. So I'm going to make an empty dot here and a solid dot here, and I'm going to make it darker, and then I'm going to erase the sides. Okay, make sure you have that, because the third one is going to be the most complicated of the three. Is a quadratic, and I know that because it has the squared here. So the x squared makes a quadratic. What's the name of the shape of a quadratic function? A parabola, yeah, it's going to make a parabola. So you guys know that the parabola is a U shape, so we're expecting something to be like a U shape. The parent function for the parabola is y equals x squared. And so I'm doing a quick sketch of y equals x squared. 0 squared is 0. What's 1 squared? 1 times 1? 1. -1 squared is also 1. And how about 2 squared? 4. And then -2 squared is 4. So this is the shape of your parabola. When you transform the vertex, the rest of the graph travels with it. So after you've moved the vertex, you can just use this pattern to know where the other points go. All right, we're going to move our vertex. We went over transformations last class. When it says x minus 2, that indicates a shift which direction?
Right.
It's good. It's to the right. Remember, it's backwards when it happens to the x. So right 2. And then how about the -5? What does that do? It is down 5 because it's not happening to the x, it's happening to the y. So down 5. Right 2, down 5. So we're going to take our vertex. The parent function has the vertex at 0, 0. So I go to 0, 0. And I go right 2, and I go down 5. 1, 2, 3, 4, 5. Make my vertex. And then I follow the pattern of the parent function. So the parent function goes over 1 and up 1 on each side. Going back to the vertex, the parent function goes over 2 and up 4 on both sides. So from the vertex, over 2 and up 1, 2, 3, 4. over 2 and up 1, 2, 3, 4. So I have these points, but before I draw it in, I want to think about which points I actually need. I only want this function when x is greater than 2. So here's where x equals 2. It says greater than, so I'm going to make an empty dot there. And on this side, I'm going to have half of the parabola. The other half landed in the yellow, so I erase it. And this is my final graph. We're going to go over this one. So for this one, it's split between the two functions at 0. So we had x is less than 0 over here. Oh, sorry. Thank you. Wait, still frozen? There we go. Okay, we had x is less than 0 over here, and x is less than 0 is what I highlighted. And then we had x is greater than or equal to 0 over here. The first one, you start at your y-intercept, and you mark -2. It says negative x, and so you had to figure out your slope, but luckily we had just done that in problem number 1. So when you have negative x, your slope is -1, and to make it a fraction, you put it over +1. So your slope is -1 over +1. You're going to go down 1, and you're going to go right 1. Down 1, and right 1. You do that a few times, and then you're going to make your line go all the way across the page. But you make it kind of light because you know you're going to erase part of it. I think that the thing that was confusing about this one is that you guys, some of you, were confusing x is less than 0 with y is less than 0. A lot of you wanted to keep this part of the line because it was like below the y-axis. That's where y is less than 0, but we're doing x is less than 0. So here's where x is 0, and x is less than 0 on this side. So we wanted to keep the left side and erase the right side. And then I'm going to make my line a little bit darker now that I know which part I'm keeping. And put an arrow. What's the last thing I need to fix on that part of the line? The endpoint, that's right. So I have to check my endpoint. It says y is less than 0. Should it be open or closed? Open, thanks Evie. Open. Okay, for the second part, I have a y-intercept of 2. So I'm going to mark +2. And I have a slope of 1/2, so that means go up 1 and go right 2. Go up 1, go right 2. So up 1, right 2. I'm going to draw the whole line, and then I'll erase the part I don't want. All right, so this line, I want it when x is greater than or equal to 0. So x is 0 here. This is the part that is greater than or equal to 0. So I erase this part. Is my endpoint correct? Yeah, so it's filled in because x is greater than or equal to 0, so that does include where x is 0 right there. And that's it. Did anybody try number 4 yet? I'm going to save number 4 because it really goes a little bit beyond what we need for this class, and I really want to focus on what we need to know right now. But if you're curious about number 4, it uses a rational function, which is what we did last class. Remember last class we graphed rational functions? And then this kind here, is this linear or quadratic? It's quadratic, good, because of the square. So rational from last class, and then quadratic would be done like this one. So you do have the tools to do this problem, but I'm not going to do it right now. I'm going to go to the back. All right, sorry. All right, write the piecewise function for the given graph. So we know the structure of it. We know it starts with like f of x equals, and then we get the fancy brackets, and it has a row for each piece. How many pieces do we have in number 4? Yeah, do you guys see how there's 2 different lines? So we need 2 different parts, like this and this. Right, so then there's going to be a place where I switch from one line to the other line, and that's going to tell me what my constraints are right here. So we know that's going to be true for this, and we have to just figure out the details. Okay, let's figure out first what our constraints are. The first line goes until x equals what number? I heard a vote for 2. You guys go with 2? Yeah, that's right. Good. So the first line goes until x is 2, and then the other line picks up right there, again, where x is 2. So that's where we're going to switch over from one line to the other. And now we have to write the equations of the lines. So remember, to write the equation of the line, we need y equals mx plus b. For the first one, you can see that the b is your y-intercept, which is what number?
4.
Yeah, it's right there. It's 4. Good. To find the slope, you're going to do rise over run. So you can pick any 2 points on the line like this and do rise over run. The rise was down 1 and the run was over 2. So what fraction would my slope be?
1/2.
Close. What kind of one? Good, yeah. -1/2. So for the first line, my m is -1/2. So when I'm trying to think about y equals mx plus b, my m is -1/2, my x is x, and my b is 4. Why is the second line a little bit more difficult? Yeah. Yeah, we can't see the y-intercept, but we could make the line longer to figure out where it is. I think it's also difficult to find the slope because it doesn't even go through like 2 distinct points here. But making the line longer should solve both those problems. You got to be really careful or you won't be able to figure this out. So when you line this up, very carefully line it up and make your line longer. Did you do it? Did you make the line longer? Okay. I still can't quite tell what the y-intercept is because it goes off the graph. We're going to find the slope first, and then we're going to find the y-intercept. So now that I've made the line longer, I can see that there are 2 points I can use for my slope. I can use this one and this one. You see that? So my slope goes up how many? 3. Good. And it goes over how many? Yeah, 1 box, right? So it goes up 3 boxes and over 1 box. So for this one, my m is 3/1, which is what number? It's just 3, right? So my slope is 3/1, which is 3. Okay, so say that I follow this slope down 1 more step. I could use that to find my y-intercept. I'm not sure exactly where it crosses, but I can figure it out from my slope. So my slope, if I go down 1, 2, 3 more, and I go over 1, I'll be right there on the y-axis. So my b is down here, -3. So by following the pattern on my slope, I was able to find that my b is -3. So this is going to be 3x minus 3. What questions do you have? What's that? Am I sure it's right? I am sure it's right.
No, no,
Okay. Yes. Good question. I'm going to explain it, okay? I went to this point right here, and I followed my slope down backwards to figure out where I would be. Notice how I'm just 1 away from the y-axis? So if I go down 1, 2, 3 more, and I go over 1, I will land on the y-axis, and then that number is -3 because I went down 3. Okay, for number 5, I'm going to put the structure up, and you guys are going to figure it out. Okay? I'll call this one g of x, just so it has a different name from f of x. Remember that instead of y, you could have g of x or f of x, or h of x sometimes. Okay. All right, so I want you guys to take a minute now. Start by trying to figure out what is the x value where you switch from one to the other, and then see if you can find the equations of those lines. All right, so we determined that the graph changed from one to the other at what x value? At -1, right. So you go till the end of the first graph, and it's an x value of -1 here. And then check the next graph. Sometimes they don't start at the same number, but this one also, it starts up at x is -1. So it's right there. Notice that I included the endpoint here because it's filled in with the or equal to. Okay, so then we had to figure out the slope and the y-intercept for this one. Your slope, some people went down 3 and right 3. Some people went down 1 and right 1. No matter what you do, though, it's going to equal what number for your slope?
1,
-1, good. So this was -3 over +3 or -1 over +1, but your m is going to be -1. And then your b, you can't see it, but if you extend the line, what number do you get? 0. Very good. Okay, so the first one is g of x equals -1x plus 0. Do you have to write plus 0? No, you could just write -1x. You could just write -x. All right, second one. The slope is up 2 and right 1. 2 over 1 equals what number? 2. Your y-intercept is what number? -1. Because it's right here where you cross the y-axis. That's it. Yes? What about the circle in the middle? Oh, I think that's an O for origin. I don't think it's meant to be part of the graph. It's just telling you like that's the origin in the middle. That's a good point. That could be distracting.
I thought it was like the same way to put the F.
Yeah, I hear what you're saying. Because actually you could have a point on this graph that all by itself, like that's a possible thing to have. But we don't have any examples of that this time. It's just labeling the origin. Any questions on this before we do the last one? All right, last one. This is not a perfect problem, and that's my fault because I made these notes, but we're going to do it anyway. You guys ready? Okay. A museum charges $5 per person for a guided tour for a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more people. Write the function relating the number of people n to the cost c. The reason why this is not a perfect example is because you can't have like 2.5 people, right? You can't have 2.5 people go to the museum, but when you connect things with a line this way, it's saying that you can have all of those numbers. So that's not perfect. So if I'm writing a function for this, it might actually look slightly different than writing a function for this. So I'm going to write a function for this graph. Okay? So for this graph, they tell me that they want to use the variable c for my y value and n for my x value. So instead of f of x, it's c of n. You see that? Instead of f of x, it's c of n. I think I can write it with my pen. That will make it easier to read. C of n. Okay. The first part of the graph has a rise of 50. You have to be careful because the boxes have, the x and the y axes have different scales. So a rise of 50 and a run of how much? You see how it goes over to the 10? So the first one has an m of 50 over 10, which is what? Yes. So you could say 50 over 10 equals 5 over 1, but that doesn't come from the graph. Like looking at the graph, it kind of looks like 5 over 4, which is confusing because it's definitely not 5 over 4. So you have to read the numbers from the graph. 50 over 10, which is 5. Okay? So your slope is 5. Your b is what number? 0. So you could write 50x, or sorry, 5x plus 0. But I'm putting the plus 0 in pencil because you don't need the plus 0. Right? Plus 0 doesn't change anything. So it could just be c of n. Oh, not x though, right? I need n. You got to stick with your same variable. And then that's going to be, n is going to be between two numbers. N is between what two numbers? Looking up here, it looks like it would be 1 and 9, right? But looking here, they've extended it to 0 and 10. However, you're not going to pay for 0 people, so I won't include it. And this function might go up to 10 people, but it doesn't include 10 people because the next part includes 10 people. So I'm just going to write it like that. All right, the next part is a flat cost of $50 no matter what. And so it's just y equals 50. That's it. Because it's no matter what is 50. So y equals 50 if the n is greater than or equal to how many people? 10 people. So sorry that's so messy. That should say 5n. Okay? And then how much does the museum tour cost for 9 people? Is he right? Is it 45 or is it 50? 45, why? But why did you choose that instead of the 50? What? Because there's not 10 people. Very good. So you have to look and see, is n going to fall in this range or is n in this range? And 9 people is between 0 and 10. So he's absolutely right. You're going to take the 5, multiply it times the 9 people, and get $45.